All right. It was really challenging for me to find like high school level stuff, but I did find a couple things that I thought were pretty interesting and that I could use in some of my high school classes. Um, this particular website, phet.colorado.edu, has got a lot of really cool like applications and simulations and whatever. And I to say it's a game is probably strong, but you can put game like aspects to it. So I'm gonna kind of say that this is kind of on the border of truly being a game and more of a simulation that can be made into a game. Um, One of the places where I thought that we could like make this into a game is some of the goals in probability are to design experiments that are simulations that will mimic the way that real world statistics work. Okay, so I'm going to just show you how it's played first. Plinko is a weird, like, I believe it's a Chinese game where there's some sort of way to gambling about which one of these places these balls are going to fall down. Now, in any sense of a gambling game, it's got to be advantage to the house. So we're going to do 10 at a time this time, and we're going to see, like, okay, where do they go? Okay, now there's quite a few in this little slot right here, and it would really be nice if we could do something to change the numbers. Okay, until you really know what's going on here, I think this is probably the best way to do it. It's where you say all of them, and then you can see all of them fall through, and then you're like, okay, what statistical information can we get from this game? Now we're assuming that there's some sort of random generator that like works with all the simulation here, but we basically get some stuff that is data driven, that a probability experiment has been made. Whether you knew it was a probability experiment or not, it has been made. Okay, so now that little click right there was important. Okay, this takes it from the game-like aspect to, okay, now we're really talking about math now. Okay, they count up here for us, and then they put things into a bin. They put 6 in the middle, and they go from 0 to 12. In the realm of a statistics class, I might have changed this like to be 0 in the middle, and then maybe negative on the left and positive on the right. But this like leads to a good discussion about why a 0 scale is good or bad. Okay, now I could take this data, I could take a screenshot of this, I could enter this into a graphing calculator, we could do some statistical analysis about it. But my idea about the game, or about maybe it's better to call more like a challenge or an exploration, was to play the game like 10 times. Okay, so this would be time 1, and then just to show you, okay, we're going to reset it, we're going to do all of them again, and it doesn't take very long for the simulation. That's why this is a cool activity. Unlike watching kids flip coins or like spin spinners and stuff like that, the 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 calculator or the computer does all the work for you. It does this grouping of the data, and you can see quite easily that it does still kind of approximate this like bell-shaped curve, but it has a different like shape to it. Okay, that was 2. I'm gonna do it a third time, and then okay, I didn't have the noise on this time, but I have a feeling it's annoying. Okay, so let's see. Yes. And some kids, they just live for that, but, listen to that all hour and all day. I might not tell them about that little ding, ding, ding thing right away. All right, that may be like 30 seconds, but like, I mean, you could do this 10 times very quickly. So I don't like the annoying noise maker. The kids would like it just because it is annoying. And then there we go. We're continuing to do that. We've got all that stuff. You can see that we're not going to always get the same kind of results. We are going to get similar results, but we're not going to get the same kind of results. And then maybe maybe you can compare 10 group of 10, or maybe you could have kids compare, okay, you've got these 10 different iterations or these 10 different trials, or like in this case 4 different trials. What can you conclude about the data? I mean, these are good things you can do, and it doesn't necessarily have to be a game to do this. Maybe, I guess the gamification part would be, could you, could you produce ideal set of data that would be normal? Okay, I'll do it one more time just to show you that we do get quite a bit of different like reactions there. Okay, I really did like this one. I mean, I teach statistics, and this is not easy stuff to simulate quickly by hand or by any paper and pencil technology. Um, for those that are less like digitally capable, like my building's not super digitally capable, you could you could show them the game being played and then give them like a variety of 10 cards with screenshots on it. It would take a little bit of teacher time preventing it, but I mean, you don't have to sit there and watch like balls fall on the ground. You can say, using your 10 sets of data, explain which ones are most normal, which ones are approximately normal, which ones, you could talk about Pearson's coefficient of skewness, you could talk about Pearson's coefficient of variability. There's lots of potential to jump off from. So, not technically a game per se, but the world of upper level mathematics really didn't lean itself towards the gameplay that we're seeing. At least the gameplay I'm exploring without like having to pay for a service. I did see some pay services that looked like they were pretty intensive, and some that were very similar to the Atlantis program that we watched on the video. But that didn't come for free, and I don't necessarily think that it's worth my investment to investigate that. That's one of the disadvantages of like the technology is like software isn't free, and it continues to go out of date and whatnot. All right, well, I would say that this one and the one I'm going to do next are very close to a game, or they can be modified to become a game pretty easily. I think that's some of the idea. I know some of the argument is like the teachers don't want to do the stuff for themselves, but here's what the lab looked like. You do have some more choice here. They do some really fancy like statistical analysis for you. So let's go ahead and like play the game for real here, and then they're talking things like binary probability, which is telling you like, okay, something different than maybe just a normal. And then there we go. We're dropping all the balls. I don't know how many balls are in this list. I just keep on dropping. Drop, drop, drop. Maybe there's 200. I don't know. I'm going to click on some of these others. I'm going to click on what path has to do with it. Okay, that saves us the trouble of looking at it. I think they're trying to basically get you to the idea that eventually that binomial probability becomes normal probability, so we're going to stop it right there. Okay, let's see what happens. We can modify it to have a simpler set of data if we don't have all that data there. Let's see what we can do there. Okay, you can control them one at a time. I have a sneaking suspicion there's a pretty good randomizing program that's making a decision about where these balls are going to. Okay, let's mess around with the binomial probability. Let's go back to that infinite cloner. And I like to watch the balls fall better than like the path. The path kind of like steals some of the glory out of it. All right, and again, they're showing you that eventually binomial, like we're skewed to the right. I mean, that's what are we doing to the data? Or if we're skewed to the left. These are all nice things to be able to talk about in a statistics class. And this could be as simple as a 7th grade discussion on statistics or an AP statistics discussion. Okay, and bells and whistles that it has. It's a pretty cool lab that you can do. And I'd maybe not game completely, but you can make it into a game. I like the other part as maybe a small group project or challenge based idea. Okay, I know I'm stretching a little bit for it, but that's kind of the idea, because like it's not supposed to be like, this game fits this particular content. It's more like, how can we make content more exciting through simulation and like experimentation. I think that's really what game-based learning and gamification is supposed to be about. Not necessarily just about, hey, I can win the game or lose the game or play the game. All right. As you can see, there's lots of things that you can do about this. You can also hide that because they're not supposed to know that. That's cool. But showing them as it happens is cool too, and really showing the impact of like what should happen as this thing approaches 50%. Like that's what it should look like. That's what binomial distribution should look like if, the random world acted mathematically. And the random world approximates mathematics models, but they are truly models, or, Vegas and, the Bahamas wouldn't exist in the gambling paradises. Because somebody's got to win sometimes. That's what all the gold stashes are built off of. All right, thank you for watching.